Here's a standard window in a metal building using R-panel. This is fairly common, probably the most common method used. Metal builders metal building builders use these J channels. They've been using them for years and years, and they've discovered a seal tight. You see the caulking line right there. It hides the caulking, which is one good thing, and they're pretty good about not leaking. The problem with them is it looks like crap. It's a thin ribbon of metal going around. It's not flush except at the very peak of these major ridges. There's this big gap underneath that's over an inch. It's an inch and 5/32, I believe, is what we've measured, and it goes all the way around, and again it just touches at the major peaks. You would think that water would pool up in that gap and eventually corrode or leak in, but they must not have a problem with that. If you caulk properly, it must not be an issue. The problem we have is how bad it looks. It's not good looking. It looks like something's wrong. It looks like there's a huge gap because somebody forgot to do something. Anyway, we have an easy solution that metal builders can use and contractors that will make their customers happy with a good looking frame to go around that. And the frame will not only look good, but it's structurally sound such that it helps give another layer against any leakage. And if for whatever reason the homeowner wants to attach something or add an accessory to the side of the building, such as say a flagpole or a flagpole holder, or I don't know, a basketball hoop, although you shouldn't put it near a window. I can picture a few items that a homeowner might want to add to the side of their building, and these Haslet frames will do the trick. To order your Haslet frames, the only thing we really need is the dimensions of your cutout. In this case, it's going to be represented by the width of the flange of these J channels. So in this case, we're talking right at 38 inches. That's the height. Now most of your exhaust fans have a square cutout. In this case, it's going to be a little bit rectangular. That's 37 3/4. Right at 37 3/4. Of course, double check to be sure it's uniform. They almost always are. And we'll be doing some editing. Yeah, it's a little less than 37 3/4 by just 1/16 of an inch, but it's close enough. And I just want to be sure we really are at 38 again. Yep. So we got 37 3/4 across and 38 inches vertical. And so we're going to order our Haslet frames 38 tall and 37 3/4 across, and I'll show you how to put those on. Cut! Your Haslet frame kit comes in 3 pieces. You'll have the 2 horizontal pieces. They will fit both for a vertical, for an R panel with vertical ridges. The horizontal pieces will fit in the grooves horizontally. The upper and lower pieces, and we'll be sure to make them long enough so that you have plenty of room to trim the piece as required. The actual formula of the shipped length is the width of your cutout plus twice the width of the vertical frame piece, or it's the same as this width, 3.5 inches. So it's going to be the width here, 37 3/4, plus 3.5 plus 3.5, which is 7, plus 12 inches in case you need to shift the whole thing over to get the For instance, right here, that's not enough to cover the width of the vertical piece, so you'll have enough material to shift the entire piece over if required. The third piece is one large vertical piece. This fits vertically, and it's unusually wide because what you will do is you will actually make your own two vertical pieces from this one component. And it's for a cutout, it's pretty easy. You would install the piece wherever it fits, but where it overlaps at a minimum amount into the cutout, you have somebody on the inside draw a line, you take it down and you cut down the length of the part. It's a rip cut. Move over 3.5 inches, make the other cut, and you have your vertical frame piece. Then you take the wastage, do the same thing on the other side. In this case, for the existing window, it's a little bit trickier. What you do is you nest it into the building, but you got to be sure to nest it where there's overlap. I'm gonna turn it around here. So right here, and we'll get a better view, it nests into the R panel pattern. It butts right there at the edge of at the corner of this vertical piece here of the window, and we make a mark, and we know that's where we need to make our rib cut. To make your vertical frames from your vertical component that you receive from Haslet products, you nest the component into the building pattern here till it nests correctly, and you make a mark. Mark the edge of the window right there, and what you should do is make some hash marks to remind you that this is the waste material and that your frame will actually be over in this region. Then I always like to repeat this process, but at the top of the cut of the window, and do the same thing. And in that case, you would take the average line here. They should be really, really close. And just to be sure, I like to repeat this working process at the top of the cutout. Again, nest it into the building panel, slide it down, and right at the edge, that, hope you can see this, right along this vertical edge, I make a mark. Make a pencil mark, do a few hash marks to remind you that this is the waste side and that your frame will be cut along this lip. That gives us two marks at the top and bottom to draw a straight line to make our first vertical frame that will fit right along that edge. For those of you who are contractors and will be doing this a lot, one of the things you can do to save a little bit of time, for most homeowners, you're just going to do this one time for one cutout. In those cases, go ahead and make your cut, then bring the waste material and repeat the process. You can save a little bit of time by going ahead and using the side that you know is going to be waste material and make your other mark for the other side. Again, I know this will be waste material, so I do my hash marks, and I know we will cut our vertical frame for this side right here. And again, I made the mark on the bottom, and I'll repeat the process at the top. If you're really sure about your measurements, you really don't have to do it at the top also. Everything should be fairly straight. So one of the first tests after we make our marks is to connect the two marks on the upper and lower ends. Technically, you don't really need two marks. If everything's nice and flush and level, everything should be perfectly aligned. However, two marks are a nice sanity check. So this worked out real well. And we got these two marks here for the other frame. And we'll connect those. And we know that we got waste material on this side and waste material on this side because we got our hash marks. The only other thing you want to double check before you cut is that you have, we know we're going to cut two 3.5 inch wide vertical frames that must come out of this section here. So we better have 7 inches, and we do. We got almost 10.5 inches across. So we got plenty of room to cut our two pieces. If for whatever reason your kit is such and your cutout or window is such that you don't get two good vertical frames out of your one component, let us know. There's a few tricks. One is go back and rotate the whole component and see if you can't reduce the amount of wastage. Try that first, but if that doesn't work, call us. We'll rush out another component for you if you need. And we've done the math though, and it should work out for a 1 1/2 pattern. In this case, it's about 19 inches. It's 18 inches, but with the flange here, this piece ends up being about 19 inches wide. And you should be able to get two vertical frames out of this one component. So next is we're going to cut down these lines. After we remove the waste material, we'll move over 3.5 inches and cut the frame off of this side, and then repeat over here. Cut off the waste material, move over 3.5 inches, and cut our second frame. Okay, just a quick fit check. Incidentally, these two vertical frames are pretty different. On the interior side, you got an obvious filler for the major ridge next to it, and this one seems awfully flat except for a chamfer here that matches one of the minor ridges, so there's no mixing them up. In your case, if they happen to be similar patterns, you might want to be a little bit more detailed on left hand, right hand. Anyway, we'll do a quick check. You got a flange here and you got the deeper filler, so it's going to fit like so. We already cut it to height. It's right at 38 inches tall, and that's a really nice fit. It's nice and level, plain to the building, and has a nice tight, it doesn't rock any, so that's going to be a good fit. So it's going to fit right here between the two minor ridges. It's going to fit a little better one way or the other. However, I noticed it rocks a little bit. I couldn't figure out what's the problem here. It should be a nice flush fit. It turns out though, we got a fastener head right here. No big deal. All you got to do is be sure you got it set right. Squeeze down, get out your pocket knife, and pick at the styrofoam filler here so that you clear this fastener head. Hopefully you don't have too many. It looks like we only have this one in the way. Okay, we got the two verticals in place. Got a clamp up. It's tricky with this window. The window only opens halfway. We'll figure out a better way to clamp later on when we install. We got the lower horizontal piece in. We got a C-clamp holding it. And again, this is just a fit check to figure out where to cut our horizontal pieces. I'll mark where to make the cut, and I'll do the same here for the upper one. And the problem with this upper one is we have these fasteners that are in the way, of course. It's no big deal. We'll take our pocket knife as we did previously. Right now I just want to trim it, or figure out where to trim. That's it. So we got everything clamped up, everything's in place. So right here, I'm making a mark. Be sure I know that we're going to cut it right here so that's even with this outer edge of the vertical frame. I'll do the same thing over here. Go ahead. Again, make an indication where I know where to cut. And just to clarify, this is all waste material. I'll do the same over here too. And let's do the same thing now for the lower piece. Yeah, it's going to be hard to get. I don't know if you can get in there. We're up against the side. That's a good fit. And it's going to be right there. Waste material that side. So we'll make that cut. I can see it right on the other side there. And we'll check this side. Same thing, be sure it's nice and flush. And we're right there. And there's our waste material. So we'll take that to our miter saw and make those cuts. And cut. So here's our mark. I'm going to take I think these are T-squares. Make a mark there to make the cut. Same thing here. Little trick, if you put your pencil lead down and then move your T-square to it, you know it's going to be right on the money. Though it never feels right. Now hopefully you have a chop saw or miter saw like this. You can do this with a circular saw, but it's tough when you don't have a big broad area. Okay, here we go. So here's the waste material. Same thing with this side. And you use these as paperweights or gifts for Christmas. Alright, that's the first one. Now technically, just to let you know, you should not have to mark which was the upper and lower. They should be identical. As long as your building is square to the center of the earth and everything's level, they should be exactly the same. However, I kind of wonder if that's always the case here. Same thing here. We encourage you to paint all the surfaces of your frames after you do your final cuts, and of course right before installation. The paint should be an exterior. We suggest an exterior water-based latex. Of course, we normally would not paint them for the customer, only because there's so much cutting involved. There'd be a lot of surfaces that would need to be repainted, and of course the customer would be the best to select the color required. So our Haslet One-Piece Frame, we do paint if the customer so wishes it, since there's no cutting involved. But for the Haslet Frame kit, we ask that the customer paint all the surfaces like these. I've got a scrap piece of our panel and a scrap piece of our Haslet frame material here, and I thought we'd talk about fasteners. You got several choices. It depends on your actual setup. In our case, the one we're actually building today, and it's very common with most of our customers, they either don't have access to the back side because of structure, which is our case. I'll show you a picture of our interior side of our window, but it's very noisy. It has columns in the way. They're structured such that we just can't get to the frames around the periphery. And so in those cases, what we're going to do is drive a sheet metal screw through the Haslet frame, which is made of weatherproof plywood with EPS filler, and the sheet metal screw will go into the R panel sheet metal, and that is the recommendation for this case. So let me go ahead and talk about that real quick. We like to use flathead sheet metal screws, number 8, which is about as small as you usually get for sheet metal. You want to be sure you get the right length. If you have calipers, do your measurement. It turns out Haslet frames for our panels are always 1 5/8 inches. So you of course you want your screw to be a little bit longer. One of the disadvantages of this type of installation is that your fastener will protrude into your interior. If it's very, very important that you not have an ugly fastener head looking at you, or if there's a safety where it's right where people might be walking by and you don't want to catch somebody on a fastener pointed in, try to sandwich it with either lumber or our Haslet interior frames, and I'll show you those in a minute. But in these cases, in this case here, we're going to drive sheet metal screws through the Haslet frame and into the building panel. You want the fastener to extend about at least 1/4 inch past. You want to get a few threads beyond the dimension. So you actually do want it to protrude. You do not want it to be exactly right on the money, because it may not actually grab the metal. So whenever possible, try to clamp up best you can. And in fact, we got a problem with our upper horizontal. We can't really clamp it. It's too far from the window. Doesn't allow a clamp to reach beyond I mean, it's almost a whole foot away, and you can't find clamps with a foot depth to them, a foot long, 12-inch throat. So this is actually a good way to install when you don't have good clamp up. If all you can do is press it together with your hands or have somebody lean on it. Another thing we need to talk about before we start drilling is the fastener pitch, which is the distance between fasteners. Some of our early instructions was every 5 inches, but that's probably very much an overkill. I've since seen some city codes, ASTM standards, where for this kind of structure, where it's not a safety factor, people aren't walking on this. If it fails, nobody's going to die or anything. This is mostly an aesthetic product, if you will. Although we do want it tight enough to stop any kind of water to to leak through. So it turns out we can probably get a good enough clamp up with one fastener every 12 inches. That sounds very far apart. If you've got a very large cutout though, that's about right. And it looks like a very logical place would be a real shadow location right here at the major ridge. But what we've discovered is at the major ridge there's actually no filler. And so the clamp up, the amount of movement or deformation or close or gapping that you close is minimal at this location, because there's nothing given. The wood is fairly stiff and the metal doesn't give at all. And so you'll pull up and it'll be a tight fit at your major ridge. But what we discovered is if you go out into the middle of the valley of your R panel, especially right in the middle at this flat zone, and put the fastener at every one of those locations, every 12 inches, you get a pretty good clamp up. And there's a couple of reasons why. One is the EPS filler does deform a little bit. It deforms more than wood does. And so it not only will be a very tight fit where the fastener goes, but it deforms enough that it will carry that clamp up over a broader area than if you just do it here. However, if you want to be super sure, we got some industrial companies who buy our product, and they put a fastener every 3 inches or so. So it's whatever you want to do. You can always add fasteners if there's ever an issue with leakage or anything. We do also, if you pretend like this is the very top of your window and this is looking down, we do recommend you put a bead of caulking along the upper horizontal piece right along the building panel, just to keep water from sneaking in behind over time. And we've had most of our customers do that, and I've never had one complain that it's leaked. So let's go ahead, and I'm going to go ahead and drill right smack dab in the middle of the low spot of the R panel. I'm going to go right in the middle. Now if you're going to do a real tight fit, I would suggest a slight zigzag pattern, but don't get too close to the edge, and right in the middle ought to do pretty good. Now keep in mind, I'm not going to drill through the entire stack up. This is a pilot hole just for the sheet metal screw. And unlike wood screws, for this sheet metal screw, it's going to be a clearance fit. It's going to be a sloppy clearance fit, and I'll tell you why. First thing I do is take this fastener, try to get a hole gauge, hole diameter gauge like this. It's well worth it. And I'll try to put the fastener through until, it goes through right here at 11/64 of an inch. It's fairly loose, and that's the drill bit I put in, 11/64. You want it to be a clearance fit, and the reason is you want it to be able to spin in the outer frame, because when it hits the metal, it actually drills its own tapping. It's a self-tapping screw, if you will, and so it actually will create the hole to go through the metal. And it's a really tight fit because it's just big enough to catch the first thread, and it pretty much creates almost like a threaded joint with the screw. So it's a good fit, and we're just going to drill through the stack up until I hit the actual R panel. And that's all there is to it. And you should be able, by hand, since it's a clearance fit, you should be able to just push it down till you hit that metal. So that's as far as it's going to actually go through. This is a Phillips head, and generally you want a flat head. I accidentally bought a bunch of oval head. I'm going to use them anyway. It's not going to matter that much. I like flat head because it just helps when you're looking at it. It's a good clean fit instead of having a big old knobby head on. And for exhaust, if you're installing an exhaust fan or any other accessory that has an attached flange, you don't want a protruding head fastener fouling a nice smooth fit up. Now in this case, for this window, it's purely an aesthetic product to make it look good, and so the only reason I would want a flat head is just to keep the fasteners out of view. But we're going to spin this for a while until it pops through on its own through the metal. Okay, here's some things I forgot to mention. One is, it would have been helpful if I had clamped up closer, but I'm pretty much simulating what I'm going to have to do coming up with this upper panel, where I cannot get clamps very close. So it took a little bit longer than I thought for it to actually tap a starting hole for the fastener, but it did eventually. One of the things I forgot to do is set my torque limiter. That's, some people call it the clutch on your driver, your battery powered driver. I would say start at 3. You can always start ratcheting up, but what you don't want to have happen is for that screw to go too deep. If it goes too deep, it looks bad. You lose some of your strength. The face sheet on the Haslet frame is generally 3/8 of an inch. We can do whatever you want, but that's the default thickness. It's better than 1/4 inch for fastener issues like we're discussing right now, and but it's thin enough that it keeps it light and keeps it from protruding too high from the R panel, the building's panel, so it doesn't look like it's a big massive piece of structure there. So, and something else we could have done, if you got the time, is to actually drill a countersink. In most cases, especially down here in where we are in Texas, most of your plywoods are going to be soft pine, and these fasteners will generally just crush the lumber such that it'll create its own little countersink without taking the time to do a professional drilling a countersink. So let me show you what the other side looks like. You can see, I believe you can see that. You can see the fastener is protruding about 1/4 inch, which is right about what you want. You want 3 or 4 threads to be coming through. Anything less than that, I'd be concerned over time that it could pull out. It's kind of interesting. I haven't seen any specs or code concerning how far a sheet metal screw should protrude past the last layer. If somebody has that information, I certainly would like to present it to everybody. But these are my own thoughts as far as sheet metal screws. And the main takeaways from this video is be sure to have a clearance hole, not interference. We could do a simulation of a interference fit where the pilot hole is barely big enough for the fastener, but what will happen is it won't be able to cut the tap the hole into the metal without lifting the whole thing away from the R panel. It would pull the Haslet frame away from. In fact, this window framing that we're doing is a little bit, it's not the most common application of the Haslet frame. The most common is to have a cutout for an exhaust fan. I bet that's about 80% of our business, either an exhaust fan or a vent for some ducting. And in those cases, you have much better access to the edge. You can clamp all the way around the edge because your frame is going, well, let's pretend like this is your cutout. Your frame is going right up to the edge. However, in those cases, we strongly recommend, whenever you have good clearance and there's nothing in the way, to have a backup interior frame to sandwich. Use the Haslet frame on the outside and have either a Haslet interior frame, and I'll show you that in a minute, or at least a flat piece of lumber on the inside. That way you sandwich the metal building panel between 2 pieces of other structure, where you can use actually use wood screws. You can still use sheet metal screws, but we recommend wood screws in those cases because most of this Haslet frame is really made for wood screws. This thin metal isn't made for wood screws, but the wood screws is going to go right through into your lumber on the interior side. So a wood screw is actually more applicable to that situation. Let me show you a Haslet frame. So we have these Haslet frames for the interior side, and when we clamp it up, you'll see that it's a really nice fit. It gives you a flat surface on the interior side. We're saying this is the inside of your building and this is the outside. Let me see if this looks any better. There we go. And then here's your exterior Haslet frame on the outside, and you sandwich your material. You have a uniform thickness all the way across for the entire stack up, and your metal building is really structurally stiff with this double frame system installed. So you can do pretty much the same thing with lumber, just about any kind of lumber, although we recommend 1x4 or 1x6 lumber. And in fact, let me show you my installation in this shop that I'm in right now. Hopefully you got enough lighting, but here's my 24-inch fan, and this is the inside of the shop, and that's standard 1x6 lumber. The advantage, of course, being it's cheaper than the Haslet interior frame, and in this case, you see that insulation with the chicken wire. It was easier to trap it with the flat lumber rather than try to cut away and staple it to the edge of my Haslet frame. So the disadvantage of using lumber is you got the gapping condition on the inside, but in most cases that doesn't really matter. Does it really matter if you've got gaps on the inside of your building if you've got it closed up on the outside? It looks good for interior purposes. If you've got a Barndominium or I'll tell you who uses these interior frames are industrial companies that have got to stop any kinds of noxious fumes leaving the building, or they got to really stop any kind of water leaks. They tend to use these interior frames. But we don't sell very many because you can do the same thing with just flat lumber also. But let's pretend like we got the Haslet frame here. We'll clamp it up. Now in this case, like I said, we recommend wood screws. And the difference between a wood screw and a sheet metal screw is very subtle. Sheet metal screw will have threads that go all the way up to the bottom of the head of the fastener. Most of your wood screws will be threaded where the shank is smooth for a good portion below. That's because it makes it easier to pull up the two pieces of lumber such that it can slip, if you will, on this portion here. Also, the threads on sheet metal screw are more uniform and smaller. There's more threads per inch. The threads on your wood screw are much coarser, and there's fewer of them. The thread per inch count is less. So whether you have an interior frame or not, one of the things you should do before you order your fasteners is check your stack up. If you need to get one of these calipers if you don't have them. They're really nice. You got these fancy digital ones, but I've gotten to where I really like this real cheap plastic. They're for less than $5 each. If you need one, can't find it, let me know. I'll sell you one. I buy them by the crate because I love leaving these around everywhere. That's 2 1/4 inches right here, and that's true anywhere I go, whether it's over a major ridge or anywhere. It's going to be 2 1/4, and so what that means is I really want 2 1/8 or a 2-inch long fastener to be sure that I go through the stack up and at least part of the interior frame. What we don't want is a fastener that's too long that breaks out and you end up with a protruding fastener looking at you with the sharp point. So I've got these. Oh, that's right at 2 1/4 inch. Let's go ahead and do this one. Problem with being right on the money is if you go too deep, if your fastener head goes a little bit too deep, it will go through. But let's give this a try. I'm kind of curious. Let's check the diameter. This goes through. Up, we're tight right there at 5/32. So I'm going to back up 2 more to make my pilot hole. My pilot hole is going to be drilled with a 1/8. So that's how I do it. If it can go through, the first time it can't go through, you don't want that one because that's practically a clearance fit. I'll go back 2 hole diameters on my little gauge here, and that's 1/8 of an inch. So I'm going to get a 1/8, and right here, and we'll drill it right here. And what we discovered is you don't need to drill a pilot hole through the metal. Now you can if you want to, especially if you know for a fact that your drill bit is smaller than the fastener. Your fastener is still going to have to cut its own threads, and you want that because it makes for a nice tight fit. What we discovered though is a lot of these wood screws will, since the threads will allow them to push against the Haslet frame on the outside, they'll actually push through and self-tap through the metal, the R panel itself. And let me show you. These have square heads on them, and I really like these square heads. All right, here we go. And my clutch is a little bit too light because that's sitting up a little bit much. See how it went down a good bit there? I can tell it's trying to come out the other side there. So, and I'm glad I'm doing this test. This would tell me if it measures 2 1/4, I need to use a 2-inch fastener. And that's actually good because that's so much easier to find and to purchase than you have to special order 2 1/4. But anyway, well, let me show it to you since we can do so. I can feel it here. You probably can't see it, but the tippy tip is right there. And again, that's why you don't want to go too deep either. So that's the 2 different fasteners. You can use sheet metal screws or wood screws if you have a wood backing. Technically, they both would probably work in either case. In fact, I do know for a fact we have many people that use sheet metal screws for this configuration. There's nothing wrong with that other than the fact that the only thing that bothers me is the sheet metal screw is not technically designed to hold in wood, but it will. And so that's perfectly legitimate also. So anyway, that's a little talk about the fasteners. Check your length, use interference fit, a smaller pilot hole for wood screws, use a larger clearance hole, pilot hole, for your sheet metal screws. Here are our painted frame details. I went ahead and used a Forstner flat bottom drill to create the part through holes to clear those nuts that are along the upper edge of the window. So we do have a difference between the upper and lower horizontal pieces. Fortunately, it's very obvious. This upper piece here will have these clearance holes, and I'll show you again and remind you about those nuts along the upper edge. Here's our 2 pieces. Now, what we're doing is we're going to drill the pilot holes for our sheet metal screws. First thing I'm going to do is measure approximately 3 inches from the end. And again, that's just a rule of thumb. If the 3 inches falls in an unusual area, of course you can move it one way or the other. About the only place you don't want to put a fastener is in the slope of the major ridge. You can actually put it in the slope of the minor ridge, but even then I'd kind of avoid that, just because it would create a weird gapping condition perhaps at the shank of the fastener. But you definitely don't want to put a fastener right there at the slope, and I'll tell you why. What we discovered is that when you install the fastener, it will hit the side of the major ridge, and it will start riding. It'll actually start riding down the side before it taps into the metal and creates its own hole. Even if you were to drill a pilot hole through the metal, your drill bit will slide down the slope of the hole. And we had cases where we were breaking drill bits, and it took us a while to figure out why our drill bits were breaking. And it's because they were bending so much because they would not eat into the side. So you can do it at the very top of the major ridge and just about anywhere else, but don't put pilot holes or put fasteners at the slope of the major ridge. Which is another reason why, just to be sure that we clear everything like that, we're going to drill our pilot holes from the inside, from the fang surface. The only problem with doing that is if you're pushing real hard, your drill bit will push the metal and they'll splinter outward. It shouldn't be so much that the head of your fastener doesn't hide it, but just be careful. Don't push real hard. Let the drill bit eat through the metal, the wood, so you don't splinter it on the outside there. So just for uniformity, I'm going to try to drill every 3 inches on each end. And this brown paint, it goes with just about every color that's generally used with these earth tone metal buildings, but it makes it hard to mark stuff. You can't see it. So this is a case where we're actually going to put the pilot hole at the top of a major ridge. So this is a 11/64. That's what we discovered is the size fastener for the number 8 sheet metal screws that we're using. So again, 3 inches, right about there. Okay, here's the case where the 3 inches falls at the minor ridge. I'm going to go right in the middle of the minor ridge. That's really 3.5. And looks like about the same here on the upper side. No, this is upper, this is lower. It'll be obvious later. And just for fun, let's look at the others. Okay, it didn't splinter. I didn't push very hard. Oh, a little bit there. Y'all see that? Yeah. And you know, it's not a big deal. We will. And you know what I'm going to do? I think I'm going to do a touch countersink just to help the heads sit flush here. I'm going to do the same thing on the other end. 3 inches away from the end. Some of our contractors who use a lot of our frames, y'all could chime in. Y'all might have discovered that, hey, you really want 2-inch distance, or you can actually go further away. We make the frames, but we rarely install them. So there's contractors who use our product who are much more knowledgeable about installation. Okay. Good deal. Okay, it turns out I'm very comfortable with these 3 pieces. They're fairly uniform across the width. The horizontals always are. And it turns out this right-hand vertical piece is very symmetrical. It happened to fall right in the middle of the very center of the pattern, so it's got 2 little chamfers, and it's very uniform. The one concern I have is this left-hand vertical piece we had to drill to stay out of the slope of the major ridge. We had to drill the hole fairly off to the side, and the only problem with that is when you install it, there's a chance that it could be a little bit tilted as it's installed and tightened down. If that's the case, we may drill a hole a little bit more into the flange itself here, trying to stay out of the slope, but pretty close to the fillet right here at this radius. So we'll just see how it fits. Now, we were talking about how you could go as far as 12 inches. That's right at 31, so that's 15 and a half. So that's a pretty far distance. So you might split that up. You take this dimension 31, divide by 3. It's a little over 10 inches. So you might do one every 10 inches here. That'll give you 2 more fasteners right there in the middle here. And I'd feel better about that than just 1 fastener. There's a, you know, the disadvantage is just the time and labor involved. You can also screw up and install a countersink too deep, and I've never been very good at drilling countersinks. One of the advantages, of course, is it's a cleaner look. I think it does make the installation a little better. Also, since we drill from the other side, we got these volcanoes of burrs and pieces of wood looking at us. We would need to knock them off anyway. You might as well do it with a countersink. So, and so one of the checks is take your fastener, turn it upside down, and you don't want it larger. In fact, I tend to do smaller. You can buy the proper diameter countersink, and maybe I should have done that. And that's about as close as I want to get. And I'll do this one here. Okay, I've got the bottom horizontal piece and the 2 vertical pieces clamped in. The bottom, it was fairly easy. I could actually reach the bottom horizontal piece across the sill of the window. The vertical pieces are more problematic. As you can see, I can clamp the bottom half of them, but the upper half is fairly loose. And so this is why we're going to have to use our clearance fit sheet metal screws. You'll see as we finish up and put the upper horizontal and we attach the upper portion of the vertical frames, that I'll push with my left hand to close the gap and drill and drive the sheet metal screw in with the other, and it'll pull up tight because of course it's a clearance fit and it will pull up. So let's go ahead and get and put in what we can right now along the bottom, since it's all clamped up, and then we'll work on the upper portion. I recommend that you always put the lower horizontal in and make sure your verticals are sitting flush, and pretty much do it right. It's easier to get to usually because it's on the lower side, and finish your frame going up from there. This lower horizontal will be your foundation, if you will. And my torque is too low, my torque limiter. That's good enough for now. Deal. Incidentally, for this DeWalt driver, my clutch is set to 9. I think it's different for every make and model. Before I get 1,000 questions about it, you see these holes that are here. There's some big old bolts that the previous owner had a satellite dish in this metal building. He parked his RV here and had a satellite dish so he could watch TV. I don't know in his RV or in the building itself, but I do need to plug those holes, but right now they're still open. I just want to let y'all know I did not do that. And here's the upper horizontal piece. Again, I went ahead and drilled a little counter bore to clear those nuts up there. It was easier, cleaner, and it looks better. Although nobody will ever see it except you guys. So that's a good fit. And last fastener here. Okay, this is the final product. I took a little bit of paint and painted over the fastener head so they're not quite as silvery and shiny, and caulked up a little bit between the butt joints, and it looks real good. The only thing I would do differently is follow my own guidelines. This window was greater than 24 inch by 24 inch. It was 38 by 38 practically. And for anything greater than 24 inch by 24 inch, we recommend the 5.5 inch wide frames. The smaller, thinner 3.5 inch frames we recommend for smaller windows, less than 24 inch. The only reason I didn't follow my guidelines is I happen to have 3.5 inch frame left over from a previous job, and it was handy to use. I might actually replace it here just to do a before and after to show you the difference. But regardless, this looks great. I might just leave it, and I just want to show you that it closes up really well. If you remember, the original J channels had a big old, almost a 1 inch gap. And here we have a real tight fit. It actually looks pretty good, and that's because it's on top of a major ridge. Now here's the other side, and it's not at a major ridge, but it still is a nice tight fit because we have our filler right down that line. And so although it is asymmetrical, this is thicker than the other side. That's just a feature of the fact that we have our panel, which is not symmetrical with all those ridges, but it's still a nice tight fit, looks good. You could get fancier with some molding perhaps around the edge, although it'd be tricky with the ridges, but it looks good. And I hope that you'll consider Haslet frames for your next modification to your windows, to your Barndominium, or for your exhaust fans. I appreciate it.